Presentation now, right?
Perfect. The stage is yours.
Thank you. Hello everyone. As already told, my name is Jonas Mertin from Fraunhofer ILT in Aachen, Germany, and I'm going to present you some of our work related to printed electronics now. So, as a first small hint, what are we doing? Who are we? I'm coming from the group film processing at Fraunhofer ILT, and we're covering in detail 5 different topics all about film processing. So the first one is about cleaning, depainting, pre-treatment of layers or substrates. Second one is about wear corrosion resistance and anti-stick layers. The third one is about energy and mobility, means in particular battery technology and hydrogen technology. And the 2 topics I'm going into detail today are printed electronics and embedded sensors, and microelectronics, in particular also by printing technology. So how's our approach towards printed electronics? We are using laser radiation sources for the additive production of electronic layers. Depending on this, we typically have about 4 process steps, not too different from those you already know from printed electronics. So firstly, we usually do a surface pre-treatment, mainly via laser radiation, but we do also use sometimes more conventional techniques like plasma treatment and so on. Secondly, we do deposition of the layers, mainly wet layers, also by industrial technologies mainly like inkjet printing, aerosol jet printing, screen printing, and so on. And then we are at the point where our main expertise comes in, which is the thermal treatment of the layers, meaning on one hand, laser-based drying, getting all the organic components out of the layer, and on the other hand, laser-based functionalization, meaning in particular the sintering and the melting of the particulate layers. If you need multi-material or multi-layers, we can do this, of course, in a loop. And the benefits we try to create are massive, as you see. But I think in this context, the main benefits come from a resource-efficient, flexible, low-cost application of sensors and layers onto 3D components, and the application of our technology only on selective area of a substrate. So, first example I want to show you about the technology is from the field of microelectronics. Here we are printing actors or microactors onto silicon wafers, which then can be used to produce microspeakers, hearing aids, and so on. So therefore, we use inkjet printing to deposit multiple layers of lanthanum nickel oxide and lead silicon titanide onto platinum-coated silicon wafers. And the printed layers are then pyrolyzed and crystallized by using laser radiation. So as you can see this here, so that we can get multiple layers. With this, we get multiple very homogeneous layers of those 2 components, which we can cure using laser radiation in shorter times, which in comparison, which one would need if he's using an oven or an RTA. And those layers later get then etched and contacted to produce these loudspeakers I was telling you about. A second application comes from aerospace, and is about the integration of functions into fiber-reinforced plastics by the combination of printing and laser technology. In particular, we are here talking about the integration of function into semi-finished products, which means we have some kind of textile which we are printing on, and which is then worked on by vacuum infusion, for example, to produce different features into the final component, like deformation sensors, integrated LEDs, or humidity sensors, which we demonstrated together with our colleagues from Fraunhofer IFAM and Wing Leading Edge to show these integrated functions. Next application is about the combination of 3D printing with printed electronics. So what we are trying here to do is printing of strain gauges onto 3D printed components. We do this by the deposition of insulation layers by a dispensing process, After that, we use eject technology to print strain gauges onto the component, and then using laser sintering to have the possibility to only sinter the strain gauge without touching, from a heat point of view, the component itself. And equipped with a wireless transmission board, we are able to do wireless integrated structural health monitoring on 2 components, which is almost all printed except for the transmission board right now. We also did some function tests with a similar structure, where we can see that as the wireless transmission as well as the signal generation by the strain gauge is working quite well to get a signal and to measure the strain. But it's not only about on a component, but also going into a component. So what we did here is having a laser powder bed fusion process, metal 3D printing process, which we stopped at one point, and then went on with integrating sensors. Again, here we are talking about strain gauges into this component by printing and laser sintering, this time with aerosol jet printing technology. And then after wiring and encapsulation of the sensors, we finished the 3D printing process. We reworked the component and then had a finally working milling head with integrated sensors, which you can use for machining your metals while measuring all the mechanical properties inside your head. So with this, I'm going to end my presentation. Thanks a lot for your attention. If you have any questions, I would happily answer them. Just contact me with the contact data you see there. And thank you.